Good morning. Welcome to the lesson on section 2.7. If you were in class yesterday, we did talk about absolute value graphs, and so today is actually going to be an extension of what we did yesterday. So let's start with an absolute value graph. So you have y equals the absolute value of x. And in spirit of the Giants actually playing good baseball last week, I'm using orange and black as our colors for today. So remember what that had equaled, right? Had equaled x, 0, or negative x, depending on the condition. If x is greater than 0, the absolute value of x equaled x. If x equals 0, the absolute value of x is 0. And of course, if x is less than 0, the absolute value of x equals negative x. The graph would look like this. It's very simple. Where if that's 1, 2, 3, 4, 2, 3, 4, and that goes at negative 1, negative 2, negative 3, negative 4. This side was like y equals x. This side is like y equals negative x. And that explains these conditions. What I want to talk about today in relation to the absolute value graph is something called piecewise functions. This is the extension of section 2.7, which is stated on page 130. So a piecewise function is exactly what we see here. That's a piecewise function. So a better way of defining it is a function defined by at least two equations. Each of which applies to different x values. Let me give you a second to copy all that. I'll be back. Okay, I'm back. I just had to go to the kitchen and get some grapefruit juice. So now I'm ready to get rolling here. So anyway, that's what a piecewise function is. It's a function defined by at least two equations, and they apply to different x values. That's exactly what we saw up here, right? We see three different equations. Y equals x, y equals 0, y equals negative x, and they all relate to different x values. So let's graph a different piecewise function. So remember, absolute value, now we know how it's like a piecewise function because it's defined by different equations, that apply different values. So let's try something different. Let's say I'd ask you to graph the following. graph y equals, okay, that's not good. I can do better than that. Here's a good one. 2x minus 1, 3x plus 1. Let's just make it negative 3x plus 1. If x is less than or equal to 1, and if x is greater than 1. So notice how y equals two different things, 2x minus 1, 3x minus 1, for different values. Here are the steps. And we'll apply these steps after I write them out. Graph first equation like you usually do. Second step, keep the piece according to x values for that equation. You'll see what I mean by that when we actually start doing this. Three, repeat steps 1 and 2 for the other equations. Okay, that's what we're going to do. So here is coordinate plane, right? Change color, going back to orange. So first equation 2x minus 1. Actually, I should do some tick marks first. Let's do that. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, back to orange. So 2x minus 1 is right here. Slope is 2, so you go up 2 over 1, up 2 over 1, and draw this guy. Alright, that's good. Now, first step's done. I graph the first equation like we usually do. Slope intercept form, find the y-intercept, use the slope to get other points, done. However, we only need to keep the piece when x is less than or equal to 1. When x equals 1, it's actually going to be right there, right? So I'm going to erase okay, that wasn't too good because it looks like I erased my whole line, but that's alright. But I'm going to erase the line and redraw the part I need. In your case with a pencil, you just erase what you don't want. But here, I just redrew the part that I need, or I kept the piece I need. So I erased the right side and kept the left side. Erase right side of x equals 1 and kept left side. Why did I keep the left side? Because it was less than 1. Remember, x is a horizontal coordinate, so it's not a matter of left or right. Less, I need the left side. Greater, I need the right side. And think about it, every single x value on the line you see right now, or actually it's more of an array, you're in from geometry, has x values that are less than or equal to 1. So that's why it's called piecewise. I only kept a piece of the first part. Let's repeat for the next one. And just to make this kind of easier for everyone, let me change the color up. I know I said I was going to only do black and orange, but we'll do red because Stanford's playing today, my favorite college football team. Negative 3x plus 1. So we start here. And actually, you know what? We probably need more of a contrast. So, sorry, we'll use green. I don't know, if you're an A's fan, green's cool, I guess. So we start 1. Move down 3 over 1, down 3 over 1. So here is the line for that. Okay, a little crooked, I apologize. Actually, no, I think I can do better. I know I can. Alright, wish me luck here. Okay, a little better. Not the greatest, but a little better. So that's the second line. However, we need to keep the part which x is greater than 1. So I will erase the line again, but knowing that I want to keep the part which x is greater than 1. I can erase that dot. That's great. Probably I'll just move the mouse over to the green dots. There we go. Perfect. Also, the thing is that it's got to be not filled in over here. We can't have a filled in dot at x equals 1 for the second line because remember, we want it to be greater, not greater than or equal to. Right? We want to be greater than. So in this case, for the green line, we erased left side of x equals 1 and kept the right side because it's greater than. And didn't fill in point at x equals 1 because it didn't equal 1, it was just greater than 1. Also notice that when you're done, so I probably should put this as a fourth step. When done, apply vertical line test. If it passes, hooray, you're happy. Because remember, this is a function, right? I use the word function here. A function for every input has to be one output. Has to pass that test. If it fails, boo. You made a mistake. And you'll need to figure out where you made that mistake. You probably didn't erase the proper portion, or you probably didn't erase anything. So make sure you keep the right part and erase what you don't need according to the conditions for x for each equation that you're given. So that's how this is graphed. This can be done in the calculator, but I'll show you guys how to do that in class. It probably makes more sense.